Welcome everyone. So today we will solve Leetcode problem 56, merge intervals. We will be solving it using Golang. So this problem states that we are given an array of intervals and each interval denotes one start and one end value. Now we need to return an array of all the non-overlapping intervals. Right. So what does this mean is that if we take this example, then we can see that this interval overlaps with this interval because because this interval's last value is greater than this interval's first value. That means they both overlap. So what we will return is we will return an interval that will cover both these intervals. For example, if these intervals overlap, then that means we will take a single interval whose first value will be minimum of the two intervals values, that for example here 1, and whose second value will be equal to the larger of both the second values, in this example 6. So if we will just insert 1 6 instead of 1 3 and 2 6, we will insert 1 6. So here 1 6 will cover the entire range of these two intervals. Similarly, we will go here, we will check 8 10 and 15 18. They both don't overlap each other, so we will individually push them to a result array. Now if we come here, we can see that 1 4 4 5 overlap at the fourth point. Now since they overlap at the fourth point, we will take a single interval whose first value will be minimum of the two values, that is here 1, and whose second value will be the larger of the two values, larger of the two second values. Here it will be larger of 4 and 5, so we will put 5. So how to solve this problem? We will solve it, since we know that we need to merge all the overlapping intervals. Now to find the overlapping intervals easily, relatively a bit ease, we will sort the intervals by their initial values. Now this will help us ensure that all the initial intervals, all the intervals that we will traverse, they will be in the increasing order of their initial values, right? They will be in the increasing order of the initial values. Now we will initially insert the first interval to our resultant array, then we will traverse all the resultant intervals, and while traversing all the resultant interval, we will check whether the current interval that we are at is overlapping with the last interval that we have pushed in our array. Now if the current interval that we are at overlaps with the last interval that we have pushed in our array, then that means we need to modify the existing interval, modify the last interval in our resultant array. Else we can just push the same interval in our resultant array as well. Now suppose we are at here, and our the last interval that we pushed to our resultant array was this, and our current interval is at this. Then we can see, since these both two are overlapping, we will modify this interval's value. So we'll modify it by first element to be minimum of the two elements, and the second element will be the larger of the two elements, that is R6, and then we will continue. So we'll follow these steps until we have traversed the array, and then we will return the result. Now let's solve this problem. First we will check if our length of intervals is less than equal to 1. If it is, then that means only one interval exists, and we'll just return intervals. Now we will sort our intervals. I'll create a separate function for this, and in this I will pass out intervals, and I'll declare the function above, sort intervals. This will take interval slice, and this will return sort dot slice intervals. This will take intervals and a function, and it will take I int j int, and it will return a boolean, and we will return intervals I 0 should be less than intervals j 0 is compare. Now we have this sorted intervals, and now we will traverse the array. First we will implement result array. Our result array will be a double slice, and and its minimum, the initial length will be 0, and its maximum length will be length of intervals, right? Because our resultant intervals length cannot exceed the original intervals length, right? Now we'll append the initial value, append the initial append the first interval to our resultant array, and then we will traverse the interval range intervals, and here we will check if our top, we'll assign top to res dot length of res -1, and we will check now if our top, this is our top value, so if our top's last element is less than current interval first element. Now if our top's last element is greater than current interval's first element, that means these overlap. Now since these overlap, no, sorry, so if our top's last element is less than our current interval's first element, that means they don't overlap, so we'll just append the result here, interval. Else if our top's first element is greater than our interval first element, no, if our top's first element is less than interval's first element. Now see, if this doesn't run, then that means they overlap, right? That means they overlap. Now if they are overlapping, we will check whether our interval's first element is greater than our current intervals, if our current interval's first element is greater than the last interval's first element. If it is, then we will assign the current interval's first element to the we'll assign the last interval's first element to the current interval's first element, right? Top 1 is equal to interval 1, and at the end we will just return res. Let's run this up and see if it works. So this is giving one error, and we can see it does. I'll try to submit it now, and we can see it works and it's pretty efficient. So again, to summarize, what we are doing here is we will check first whether they overlap or not. Now if this doesn't run, that means they overlap. Now if they overlap, we will find the larger elements of the second value, and we will put the larger of the second element's value to the last element that we have pushed in our array. So here we will modify 1 3 to 1 6, and then we will take on this array, because 1 6 will cover these two elements, right? So let me know if you guys have any question. This is all for today. Bye.